In this video, I am going to try to find the solutions to second order homogeneous differential equations with constant coefficients. I will consider the special case where the roots are repeated, meaning the characteristic equation has the same two roots. So let's go ahead and start with our venture here. So we know that our general format for the solution is going to be y is equal to, or let's call it y1, is equal to e to the power rt, right? So if I take the derivative of it, it's going to be y1 prime is equal to r times e to the power rt, and y1 double prime is going to be equal to r squared times e to the power rt. Now if I plug it into this equation and simplify it a little bit, I'm going to get a r squared plus b r plus c times e to the power rt is equal to 0. Now e to the power rt is not actually 0, never 0. So this cannot be equal to 0. Therefore, the characteristic equation has to be 0, right? So a r squared plus b r plus c is equal to 0. This is a quadratic equation and we can solve it very easily. R is going to be equal to negative b plus or minus square root of b square minus 4 times a times c, all of it divided by 2 times a. There are three scenarios for this solution when the roots are distinct, meaning that scenario 1, when b square minus 4ac is positive, meaning greater than 0. In that case, you will have two distinct solutions. What if the second case, where b square minus 4ac is equal to 0? In that case, you have one root repeated twice. And by the way, this is the scenario we are going to analyze in this video. And the next, number 3, when b square minus 4ac is less than 0, then you have two complex roots and they are conjugates of each other. We are going to talk about the third case and the first case in another video, but this video is for the second case. So let's go ahead and apply that. If b square minus 4ac is 0, your r becomes, so this term becomes 0, right? Square root of 0 is 0. R becomes negative b over 2a. So your solution, okay, becomes, let's say, y1 is equal to e to the power negative bt over 2a. So that's your solution. That's one of the solutions. However, what is the other solution? How do we find the second solution? Now, you kind of have to think of it in a way slightly what you are used to. If you have two distinct solutions, okay, for y1, one value in the form of e to the power something, and for y2, another value in the form of e to the power something, right? They are not linear combinations of each other. So that's very important to remember. So let's say, for example, if one of the solutions is e to the power t, and let's say the other one is e to the power negative t, then these two are linearly independent, meaning that one is not a linear combination of the other. What it means in ordinary people's term is this: you cannot multiply one of them and get the other. That's what it means. All right? So we know that fact. So using that knowledge, we kind of have to explore things. So what we are going to do, we are going to claim, okay, let's say my solution y of t is going to be, of course, I have e to the power negative bt over 2a, but it's going to be that thing times some other function that I don't know yet. And let's call it u of t. So some other function I don't know, And the new solution or the second solution would be the product of u of t and e to the power negative bt over 2a. And our job here is going to be to find out what is this u of t. And if we can find it out, then we will have two solutions, linearly independent. One is not a multiple of another. And then we do have a general solution. So let's go ahead and do that. We are going to follow the standard game here, nothing out of the ordinary. So y of t is this value right here, according to our assumption. Remember, this is an assumption, okay? This is some exploration, something you are trying out. Think of it that way. So in that case, let's see what happens if we try this out. So y prime of t is going to be, I'm just going to avoid writing the t all the time, u of t. Just I would write u. So it's going to be derivative of the product. So there's going to be u prime e to the power negative bt over 2a plus, actually it's going to be minus negative b over 2a times u times e to the power negative bt over 2a. I just found the first derivative of the assumed solution. So now I'm going to go ahead and try to find the second derivative of it, which is going to be y double prime of t is going to be u double prime e to the power negative bt over 2a, then minus b over 2a u prime e to the power negative bt over 2a. So that's just the derivative of this. Now I gotta take the derivative of this. So don't forget the negative sign and make sure to distribute it. If you do the things properly, you should get negative b over 2a times u times e to the power negative bt over 2a, then plus, the next term is going to be plus because you're going to get a negative sign from here by taking the derivative of e to the power negative bt over 2a. So it's going to become plus, okay, so I have to be careful here. So there is already a b over 2a, so it's going to be b square over 4a times u, right, times e to the power negative bt over 2a. So let's make sure that you follow this step carefully, okay? It's very likely if you pay a little less attention, you'll end up making a mistake. All right, so that's my y double prime. I found y prime, and let's go ahead, and also I have y, right? Let's go ahead and plug it into our original equation, which is this. A y double prime plus b y prime plus c y is equal to 0. I'm going to plug all these values. So a times y double prime, I'm just going to multiply it out. So it's going to be this. So u double prime, and I'm going to leave all of these e to the power for the end because each of these terms are going to have e to the power negative bt over 2a. So it's going to be a u double prime minus a times b over 2a, so it's going to give me negative b over 2 u prime, and this one is going to give me negative b over 2 u, and this one is going to give me positive b square over 4 u, and then that's just a times y double prime, then b times y prime. So b times y prime is this, right? It's going to be plus b times u prime minus b square over 2a. And I made a mistake. I just realized this should be for a square. This should be 4a because you already have a b over 2a, then you'll have another b over 2a coming in from the derivative, right? So that's going to give you b square over 4a square. So b square over 2a u, then that's b times y prime. So b times y prime, next c times y, plus c times y is just c times u, and the whole thing multiplied by e to the power negative bt over 2a, and that has to be equal to 0. However, the exponential term is never going to be equal to 0, so the other factor is going to have to be 0. Now, I realized that I made a slight mistake, and let's clarify that. This should be actually u prime, okay? If you do the thing properly, you will see this should be u prime because you're taking the derivative of u, okay? So that makes this guy u prime. All right, as it turns out that this kind of becomes something very nice and simple. Look, these two, this, and these are going to cancel out, all right? Because negative b over 2 u prime, negative b over 2 u prime plus b u prime is going to cancel out. Then you're going to be left with a u double prime, then negative b square over 2a, positive b square over 4a, both of them multiplied by u. If you simplify it, it's going to be negative b square over 4a times u plus cu. And all of it must be equal to 0. Now, we could simplify it further. A u double prime minus, if I combine these two terms, I'm going to get negative b square minus 4ac, all of it divided by 4a times u, okay? And that is equal to 0. However, our assumption was that b square minus 4ac is equal to 0. That's the case we are covering, right? So this term is going to go down to 0. That leaves me with nothing but a u double prime is equal to 0, or equivalently u double prime is equal to 0. If I integrate both sides, I'm going to get u prime is equal to c1, some constant, arbitrary constant, since the derivative is 0. If I integrate it again, I'm going to get u, or u of t, is equal to c1 plus c2 times t, okay? So that's what my u of t is. Now, what I need to do, I need to take this u of t and substitute at the original value. So my y of t is going to be u of t. So it's going to be c1 plus c2 times t times e to the power negative bt over 2a. Now, if I simplify it a little further, I'm going to get y of t is equal to c1 times e to the power negative bt over 2a plus c2 times t times e to the power negative bt over 2a. And this, by the way, should be the general solution to this differential equation, second order homogeneous differential equation with constant coefficients where the roots are repeated. The characteristic equation has repeated roots, and that's how you in general solve a second order homogeneous constant coefficient differential equations. I hope that this discussion was helpful, and thank you very much.